do we require to configure STP? Why do we require to enable this STP on all switches, right, in your switched network? And because if you don't enable STP and if you are having redundant link in your switched network, then definitely there will be a bridging loop. And if there is bridging loop, then you know very well that the lane users, your lane users behind any switch will not be able to communicate with each other, right? For some time, of course, for some time they will be communicating with each other, but then after all they won't be able to communicate with each other, right, due to bridging loop. Now we says that STP will be responsible to prevent your switched network from bridging loops, right? So now question is that how does it prevent your network from bridging loops? I got one point. Now big question is that how does it prevent your network, your switched network, from bridging loops, right? So if we talk about the STP, then we have to understand its functionality, because as I said earlier on, that STP will always put your alternate interfaces, right? STP will always put your alternate interfaces into blocking state, right? Yeah, that will definitely happen, but now we need to understand that how does it really take decision, right? How does it really takes decision that which interface should be in blocking state and which interfaces, which ports must be in forwarding state. So we have to understand the background process performed by STP to elect all these interfaces, right? Okay, so if we are talking about like for an example STP, then let's say that we are having here two switches. Let's say it is switch 1 and this is switch 2. So here we are having these two switches available, and even if you are having only one connection in between these two switches, then also STP will be running it in between these two switches. Doesn't matter, because by default it is enabled, right? So because STP is by default enabled on all switches, that is why now STP will be working on by default, right? It means that now you know very well that in STP, first of all, they will elect their root bridge. So I don't think so that any one of you having any problem with the root bridge election, because all of you know very well, understand very well that to elect root bridge, of course, it will compare their bridge IDs, right? So basically root bridge election will be based on bridge ID. And if you talk about the bridge ID contains two components, mainly two components. One is bridge priority and bridge MAC address. Is not it? Bridge MAC address, and this MAC address will be its base MAC address, not its interface MAC address. Fine. So do not understand it in that way that okay, this MAC address will be belonging to any interface. No, this MAC address will never belong to any specific interface, right? This MAC address will belong to your device. Actually, it will be device's MAC address. That is why we call it base MAC address. You understand? So bridge ID, bridge ID is made up with the help of two components, bridge priority, and second is what? Bridge MAC address. Fine. One more thing. Best bridge ID, a switch with having best bridge ID will always become root bridge. Now how will you evaluate that which bridge ID is the best bridge ID? First of all, you will compare their bridge priority. Out from their bridge ID, first of all you will compare only their bridge priority. If bridge priority is common, you understand, as you know very well that by default bridge priority is 32768. So of course, based on bridge priority, switches will not be able to elect their root bridge. Fine. So because now they are not able to elect their root bridge based on bridge priority, then of course they will be using bridge MAC address as a tiebreaker. Here they will be using bridge MAC address as a tiebreaker. So of course you know very well that base MAC address cannot be same on two different switches, right? So of course any one of them, either switch 1 or switch 2, will be having best MAC address, best bridge MAC address. You can also call it switch ID, switch priority, switch MAC address, right? Because previously this STP was launched for bridges only, because before switches we were using bridges, but nowadays we are using only and only switches, but technical terms are still same, right? That is why we are calling it as a bridge ID. Fine. So bridge ID contains two things, bridge priority and then bridge MAC address. First of all, switches will compare their bridge priorities. If bridge priorities are common, then definitely they will use bridge MAC address as a tiebreaker, and finally your root bridge election will be based on bridge MAC address if their priority was common, and by default definitely all switches will be having same common bridge priority. So definitely by default your root bridge election will be performed based on their base MAC addresses, right? So you can see now that how I hope that now you have understood that how will they perform their root bridge election, right? But now the big question is that how will it be possible for switch 2 to know the bridge ID of switch 1, and how will it be possible for switch 1 to know that what is the bridge ID of switch 2? How will they compare their bridge IDs with each other? Of course, to exchange their bridge IDs with each other, you understand? To exchange their bridge IDs with each other, they will send BPDU messages. Like for an example, if you are going to configure OSPF or EIGRP or like BGP in between two routers, right? So like as you have already seen that in case of OSPF, first of all they exchange their hello messages and then they compare their parameters. If parameters matches, then definitely they will form OSPF neighborship. Your OSPF neighborship will come up. If their parameters do not match, then definitely OSPF neighborship will not come up, right? So in same manner, like here, if we are saying that switches will exchange their switches are gonna to elect their root bridge based on their bridge IDs, so it means that all switches must access their bridge IDs information with each other, right? So for that purpose, STP is also having hello messages, same as OSPF and EIGRP have their own hello messages, right? So in STP also we are having these hello messages, and these hello messages are basically known as BPDU messages. Have you understood it? So BPDU is what? Bridge Protocol Data Unit. Now, if you talk about the BPDU messages in STP, we are having two types of BPDU messages available in your STP. So if you talk about the BPDU, then we are having two types of BPDU here. One is configuration BPDU and another one is TCN BPDU, right? So remember that only and only configuration BPDU will be generated by switches periodically in every 2 seconds. We always says that, we always says like switches will be responsible to generate BPDU messages in every 2 seconds. And one more thing, remember that in STP, after election of root bridge, only root bridge will be responsible to generate BPDU messages. Fine, in every 2 seconds. I'm talking about configuration BPDUs only, not TCN, right? So remember that configuration BPDUs will be generated by root bridge only after election of root bridge. Once root bridge election is done, then definitely only and only root bridge will be responsible to generate BPDU messages. So I hope that you have understood it now, right? So remember all these things. And if you talk about the TCN BPDU, they are event driven actually. They will be generated by STP. Time kya hua? All right. So as I said that configuration BPDU messages will be generated by root bridge only after election of root bridge. And if you talk about the TCN BPDUs are event driven actually. Like whenever there will be any change on any switch, then that switch will be responsible to generate TCN BPDU. TCN is topology change notice. Topology change notice, or you can also call it notification. Fine. So topology change notice BPDUs will be generated by that switch wherever, where a change occurs, right? Whenever any change will occur on any switch, that switch will be responsible to generate that TCN. And what is the uses of this TCN? I will be discussing it with you later on. But first of all, we must understand that what are the components contained by configuration BPDU and what are the fields available inside the TCN BPDUs. Which kind of information is contained by configuration and which information is contained by TCN. So let's talk about the components of configuration BPDU first of all. Components of configuration BPDU. First of all, it will be having version, then protocol field will be there. I think protocol ID is there, right? Or something like that. Then third one is what? Type. Fourth one is what? Flag. Fifth one is what? Root bridge ID. Sixth one is what? Designated bridge ID, right? And then yes, cost to reach root bridge, then designated port ID, then message edge, message, then you are having here forward delay timer, and finally hello timer. So these 12 fields are available. These 12 components will be contained by configuration BPDU. Here remember, in STP, version field will always contain 0, protocol ID will also contain 0 in STP. Then type will be responsible to specify whether it is configuration BPDU or TCN BPDU. That will be specified by this type field only. Flag, this is actually TCN flag. This flag is what? TCN flag, and later on I'll be discussing the uses of this TCN flag with you. Then root bridge ID is there, designated bridge ID is there, cost to reach root bridge is there, designated port ID is there, message edge is there, message is there, forward delay, and hello timer. For now, it is enough to know that what is the meaning by root bridge ID and what is the meaning by here designated bridge ID, and all other things I'll be discussing later on, right? In future I'll discuss each and every component of this configuration BPDU, don't worry about that. But for now, for us, the most important thing is what? Root bridge ID and designated bridge ID. So this information will be contained by configuration BPDU. So remember, let's say for an example, now you are having two switches. Let's say this is switch 1. And this is what? Switch 2. You have interconnected these two switches together now with using 0 by 1. And now after, of course, whenever switch will come up, it will always announce itself as a root bridge. Remember that whenever a switch comes up, it always assumes that it is a root bridge. So whenever it will assume that it is a root bridge, then definitely it will be responsible to generate configuration BPDU, right? So now switch 1 will send configuration BPDU towards switch 2, and switch 2 will also generate configuration BPDU in the direction of switch 1, right? So switch 2 will give its own configuration BPDU to switch 1, and switch 1 will also give its configuration BPDU to switch 2. So when switch 1 will send its own configuration BPDU towards switch 2, then of course switch 1 will also specify, I mean in that BPDU you will find, I mean switch 2 will find the bridge ID of switch 1, I mean designated bridge ID and root bridge ID, both components, right? And this time, because switch 1 is announcing itself as a root bridge, let's say its MAC address is A and its MAC address is B. So whenever switch 1 will generate configuration BPDU, because switch 1 is assuming that it is assuming itself as a root bridge. So because switch 1 is saying that I am root bridge, so it will be responsible to generate configuration BPDU. In that configuration BPDU, if you talk about those two fields, one is root bridge ID and another one is what? Designated bridge ID. So if you talk about the root bridge ID, it will be bridge ID of switch 1 because it is assuming itself as a root bridge, and also because it is transmitting BPDU out from this interface, so it will also specify its own bridge ID as designated bridge ID. So in designated bridge ID as well as root bridge ID, switch 1 will be having its own bridge ID. Fine. In same manner, switch 2 will also be having root bridge ID and designated bridge ID as its own bridge ID, right? So switch 1 will give its BPDU to switch 2, switch 2 will also give its BPDU to the switch 1. Now whenever switch 1 will receive this BPDU coming from switch 2, switch 1 will come to know that, okay, no, I'm having my best bridge ID, right? My bridge ID is the best, right? Because whenever switch 1 will receive BPDU coming from switch 2, it will compare its own bridge ID, and you can see here that switch 1 is having best bridge ID. So switch 1, whenever switch 1 will receive this BPDU coming from switch 2, it will assume that, okay, no, I'm having best bridge ID, so I must be a root bridge, right? So it will keep on to announce itself as a root bridge, and also will keep on to generate BPDU messages in every 2 seconds. But whenever switch 2 will receive this configuration BPDU coming from switch 1, it will compare its own bridge ID and it will come to know that, okay, no, I'm not a root bridge, because switch 2 this time will receive the superior BPDU, right? May switch 2 will receive this BPDU with best bridge ID. So switch 2 will immediately stop to announce itself as a root bridge and will accept switch 1 as a root bridge. Have you understood it or not? So first of all, all switches will announce themselves as a root bridge. And when a switch receives a superior BPDU, do you understand the meaning by superior BPDU? Means a BPDU with best bridge ID. So when a switch receives a BPDU with best bridge ID, then it will always stop to announce itself as a root bridge and will accept that switch from where it received superior BPDU as a root bridge. Is not it? So this is the primary function performed by all switches. Fine. Now this is that how do they perform? How do they perform? Root bridge election. Okay. Now put this root bridge election aside and now let's talk about the port states. You know very well that in STP we are having two types of interfaces. One is DP, which is known as designated port, right? We are having two types of ports here in STP. One is designated port and another one is what? Non-designated port. We are having only two classes. One is DP and another one is what? Non-DP. Remember that DP will always be in forwarding state.
Yes.
DP will always be in forwarding state. And if we talk about the non-DP, remember that non-DP again will be having two types of interfaces. One is RP, will always be in forwarding state, and one is alternate, which will always be in blocking state. So under non-DP you are again having two types of ports. One is RP, pushkin, and another one is alternate port, which will always be in blocking state. Fine. So here we are having majorly we are having only two classes of interfaces of ports. One is DP, another one is what? Non-DP. DP will always be in forwarding state. Under non-DP, RP will always be in forwarding state, whereas alternate port will always be in blocking state. Now, big question is that how will it be possible for STP to elect DP and non-DPs? How do they elect their DPs and non-DPs? So it is very simple. If we talk about the root bridge, if we are taking an example of root bridge, let's say that you have defined any switch as a, let's say switch 1 became as root bridge, right? So there is a simple rule for root bridge that all interfaces, all ports of root bridge will always remain as DP and in forwarding, because DP will always be in forwarding state. There is a rule for DP, right? So remember, all ports of root bridge will always be DP except one condition, right? Remember that all ports of root bridge will always remain as DP except one condition, and that condition can be something like this. Let's say this is switch 1 and it has been configured as a, there is a hub. Hub do not understand your STP. So now let's say this is 0 by 1 and this is 0 by 2. If it configure both of them as DP, of course there will be a loop. So any one of them will become now backup port in this type of network, right? Either 0 by 1 or 0 by 2 will become backup port. In that case, both of them will not be DP actually. One will be DP, another one will be backup. And backup will always be in blocking state. In this condition only. Otherwise, if you are not using hub, then definitely all ports of root bridge will always remain as DP. So I don't think so that will there be any problem for you to elect your DP on root bridge especially, right? Okay. Now forget about root bridge. Let's talk about RP election and DP election between two non-root bridges. Are you getting my point? Because DP can also be elected in between two non-root bridges as well. So if we talk about the RP and DP election process, very first thing is what? Very first criteria will be lowest cost to reach root bridge, and this rule will be applicable for DP election as well. But in that case only, whenever you are going to elect your DP between two non-root bridges only, because if your switch is root bridge, then definitely its all ports will be DP, then there will not be any type of election. Second is going to be, if your cost is equal, then they will compare their designated bridge ID. Designated bridge ID. If it is also common, it is also same, then finally your tiebreaker will be designated port ID. Now I'll be discussing all of them with you, that how does a switch, how a switch use all these parameters to elect their RP and DP. Fine. So these three parameters are there, or you can say these, the primary criteria will be lowest cost, and then other criteria will be used as a tie breakers. So let's take an example of DP and RP election and all, right? So for an example, if you are having this switch 1 and this is your switch 2, this is 0 by 1, this is 0 by 2, and this is, let's say, 0 by 2, and this is what? 0 by 1. Its MAC address is A and its MAC address is what? B. So first of all, both of them will announce themselves as a root bridge. Switch 1 will say I am root, switch 2 will also say I am root. So both switches will say that we are root. Switch 1 will send BPDU in the direction of switch 2, switch 2 will also send BPDU in the direction of switch 1. Now any one of the switch will receive superior BPDU, either switch 1 or switch 2. So which switch is gonna to receive superior BPDU in this case? Switch 2. Switch 2 will be receiving superior BPDU because switch 1 is having best bridge ID. So switch 2 will receive superior BPDU. Superior BPDU means best bridge ID. A BPDU which is having best bridge ID. So of course switch 2 is going to receive superior BPDU. Once switch 2 will receive the superior BPDU, it will immediately stop to announce itself as a root bridge. Now it is not going to announce itself as a root bridge. Fine. So of course because switch 1 is going to be now root bridge, right? It will be elected as a root bridge. So as I said that all interfaces of root bridge will be DP. And now remember that in a segment both ends cannot be DP or cannot be non-DP. In a single segment, both ends, like here on this cable, both ends cannot be DP as well as cannot be non-DP. And if it is something like that, it means there is any type of problem in your network, and there can be a bridging loop now. Ideally, in a single segment, both ends must not be same, either DP or non-DP. In a single segment, if one end is configured as a DP, then another, in that case, another end must be configured as non-DP. It must be non-DP. Fine. So because here at the end of switch 1, both interfaces have become DP. So here on switch 2, of course, it will perform now RP election. Remember that you will never be able to find RP on root bridge. You will never find any RP root port, or you can say non-DP port, non-DP, non-designated port on a root bridge. Never ever, right? So remember that under non-DP, as I said, that there will be RP and alternate ports, right? Blocking ports. So here, because both of them see have become now DP. So here on switch 2, any one of them will be RP and another one will be alternate port in blocking state, right? So first of all, we have to elect RP. Now to elect RP, first of all, I said that they will compare their cost, lowest cost to reach root bridge. Now remember that root bridge in STP will be responsible to generate zero cost BPDU. Zero cost BPDU. So by default, root bridge will generate zero cost BPDU. Means that whenever a root bridge will generate a BPDU configuration BPDU, in that it will specify the total cost to reach root bridge as 0. So here one more thing you must remember, that a cost of that interface through which your switch is transmitting BPDU messages is sending BPDU messages will never be added into total cost to reach root bridge. Here we will be talking about the cumulative cost, like same as OSPF. Do you remember the process of OSPF? Like whenever a route was received on any interface, then the cost of that interface only was added into total cost. The cost of that interface from which you were transmitting out, I mean you were sending out your prefix information, the cost of that interface was never added in OSPF, right? That is why we are calling it as a cumulative cost. So what is the meaning by cumulative cost? That only and only receiving end cost will be added. So here, because you know very well that IEEE has also defined some default cost values for your interfaces, like for 10 Mbps, if the bandwidth of your interface is 10 Mbps, of your port is 10 Mbps, then the default cost will be 100. For 100 Mbps, your default cost will be 19. For 1 gig, it is gonna to be 4, and for 10 gig, it is gonna to be 2. These are the default cost values for your links defined by IEEE. If your link is having 10 Mbps bandwidth, default cost will be 100. 100 Mbps interfaces will be having default cost as 19. 1 gig interfaces will be having default cost as 4, and 10 gig interfaces will be having their default cost as 2. So you must remember all these things. So let's say that here we are having 100 Mbps bandwidth. I mean, we are using these links of 100 Mbps bandwidth. So by default cost will be here 19. Here also will be 19. Here also it will be 19. Default cost here also it will be by default 19. So because as I said that switch 1 will be responsible, because switch 1 is working as a root bridge, so it will be responsible to generate zero cost BPDU messages, right? So whenever a switch 2 will receive this BPDU here on its 0/2 and 0/1, whenever switch 2 will open, the cost to reach root bridge on received BPDU on its 0/2, it will find that the total cost to reach root bridge is what? 0. But then after it will add its own cost into that. So its own cost is what of this interface? 19. So from here total cost is going to be now 19. From 0/1 also total cost will be 19. So total cost to reach root bridge out from both interfaces is 19. So of course RP election will not be done based on cost. Next,
bridge ID. Lowest and the bridge ID.
Lower designated bridge ID. See, whenever, try to understand it now, whenever a switch 2 will receive BPDU here on its 0/2, whenever switch 2 will receive this BPDU here on its 0/2 coming from switch 1, designated bridge ID will be bridge ID of the designated switch. Who is the designated switch for switch 2? I mean upstream switch. Designated means upstream. So who is the upstream switch for switch 2? Switch 1. So whenever switch 2 will receive any BPDU on its 0/2, designated bridge ID will be bridge ID of switch 1. And whenever switch 2 will receive BPDU on its 0/1, then also designated bridge ID will be bridge ID of switch 1. So on both interfaces, switch 2 will find same designated bridge ID. It means based on designated bridge ID also switch 2 won't be able to perform RP elections. Have you got it? Finally, it will compare lowest designated port ID. Designated port ID. Port ID contains two things. Again, port priority and interface ID. Priority is by default, and then interface ID something like 0/1, 0/2, something like that. Is not it? 0/3, 0/4, 0/6. Got it? Okay. and it will be designated port ID. So we'll switch to compare its own port priority and port interface ID, or designated port priority. Designated, because in receiving BPDU it have also received designated port ID, means port priority of switch 1 0 by 1, port priority of switch 1 0 by 2, as well as their interface IDs. In received BPDU on it 0 by 2 and 0 by 1. So you will not compare switch 2's port ID, you will compare switch 1's port ID, because you are talking about the designated port ID. So who is the designated switch for switch 2? Switch 1. That is why switch 1's port ID will be compared. Have you got it? So this time you can see that by default port priority will be 128 here. Here it will be 128. So finally decision will be done based on interface ID. So 0 by 1 or 0 by 2, which one is lower? 0 by 1. So that is why here on switch 2 0 by 2 is gonna to be RP, and it will move into forwarding state. And one more thing here, because it is DP, so another end must be non-DP, and under non-DP you can have either RP or alternate port, and one switch, one non-root bridge, because it is working as a non-root bridge. So on a single non-root bridge you can have maximum one root port, you cannot have more than one root port. So RP is already elected here, so because it is DP it will be non-DP, so definitely it will be alternate port and will move into blocking state. So in this way it will elect its RP and DP if you are taking two switches, right? And if you are having a redundant link in between those two switches, so in this way it will perform fine. Okay, this is one example. Let's take another example of STP process. Let's say this is switch 1 here. This is switch 2. This is switch 3. Fine. Let's say this is 0 by 1. A. Which switch will be elected as a root bridge? So this time any one of this switch among all these three switches will become root bridge, right? Either switch 1, switch 2 or switch 3. Today I think ACs are not working. Okay, so switch 1 is going to be root bridge now. So it will be elected as root bridge, so it means both interfaces will become now DP. And remember that DP will always transmit BPDUs, right? It will receive here. Now because switch 2 is not gonna to be root bridge, so of course it will elect RP. It will compare cost. So here it will receive 0 cost BPDU. Total cost will become from here. And if BPDU is coming from this side, then here it will receive 0, but before transmitting it towards switch 2 it will add the cost of 0 by 2, right? This switch 3. I got your point? Yes. So here switch 2, whenever switch 2 will receive BPDU, it will open that BPDU, we'll see that the cost, root path cost is what? 19. But then it will also add its own cost, right? So that will become root path cost, right? So it will become now 38. Which one is having better? 19. So of course that will become RP. So here it is going to be RP. In same manner, switch 3 can also have this 0 by 1 or 0 by 2 as RP, but any one of them will be elected as RP. So of course you know very well that this 0 by 2 is going to be RP, root port, right? Okay. Now let's talk about this segment. If both ends are configured as DP, both of them will become will move into forwarding state, and if they moves into forwarding state, then again there will be a bridging loop. As I said that both ends in a single segment, both ends cannot be either DP or non-DP. So now they cannot be either DP or RP or blocking. They cannot be, right? So first of all they will elect their DP actually. that which one will be DP and which one will be non-DP. So let's elect DP, then non-DP will be elected automatically. So here let's elect their DP in between switch 2 and switch 3. And as I said earlier, that if you are going to elect DP between two non-root bridges, is there any one root bridge in between switch 2 and switch 3? So this time you are going to elect DP between two non-root bridges. So your election process will start from cost. Fine. So DP will be that port which is having lowest cost to reach root bridge. So here you see BPD will be generated by switch 1, switch 2 will receive it and will transmit it towards switch 3. So from here total cost is going to be 38. And this time switch 1 will also send BPDU towards switch 3. Switch 3 will also transmit these BPDUs towards switch 2, right? So from here, after receiving BPD here, total cost will become 38. So from both ends you can see the total cost to reach root bridge is same. And never calculate cost in this manner here, because sometimes what will you do actually, it was RP actually, you will compare cost in this way, okay, from here and okay from here. It will never happen, because here it will never receive BPDU from switch 1 and then switch 3 and here on this interface, never ever. It will transmit BPDU from it, right? So if it receives BPDU on this interface, it means it will be coming from switch 2 only. So you will calculate cost in this manner, like from switch 1 to switch 3 and from switch 1 to switch 2, in this way you will compare its cost, right? So now cost to reach root bridge is what? Same. Then finally designated bridge ID. Designated bridge ID will take place now. Next tiebreaker is what? Designated bridge ID. So if BPDU is generated by switch 1, switch 1 will give it to switch 2 and switch 2 will transmit it in the direction of switch 3. So whenever switch 2 will give that BPDU towards switch 3, now in that BPDU inside designated bridge ID it will be having its own bridge ID. Means that whenever switch 3 will receive this BPDU on its 0 by 1, in that BPDU inside designated bridge ID it will find bridge ID of switch 2. However, root bridge ID will remain same, bridge ID of switch 1, because switch 1 is still working as a root bridge. In same manner, switch 1 will give its BPDU to switch 3, switch 3 will give its BPDU to, switch 3 will send a copy of that BPDU towards switch 2, right? So whenever switch 2 will receive this BPDU here on its 0 by 2, it will find designated bridge ID. So which one is having lower bridge ID? So of course they can compare it very easily. So switch 2 will think that I am DP, and of course here at the end of switch 3 it has to be non-DP, and under non-DP you have only two things, either RP or alternate. RP is already there, then definitely it is going to be alternate, and alternate port will always be in blocking state. That's it.